Hello everybody! In this video, we're going to be talking about the axis keyword argument in a little bit more depth. This is one of those topics that can be a little bit confusing the first time you see it, so hopefully after this video it makes a little bit more sense. And the first thing to think about is that axes are just a way of referring to dimensions of an array. So we have the rows, we have the columns. These are different dimensions of a two-dimensional array, for instance. So for that reason, it makes sense for us to only talk about axes if we're working with arrays that have at least two dimensions. So in this video, we're going to be thinking about the two-dimensional case in particular. So again, in the two-dimensional case, axis 0, this is the rows axis, and you can think of it as having rows as elements. If that doesn't make sense, I think a little bit more intuitive of a way is imagine that we have this arrow running vertically from top to bottom. Similarly, we say that axis 1 has columns as elements, and we imagine this horizontal arrow running across the columns of the array. So for instance, if I wanted to add up these 4 elements, I'd be moving in this direction, so I want to use axis 1. If I want to add up 1, 5, 9, for instance, then I'd want to use axis 0 because I'm moving in this direction. So I've already talked a little bit about it, but how do we kind of conceptualize this idea? Well, there's a couple main situations where we're going to be dealing with this axis keyword. So one of them that you've already seen is when we're taking maximums or we're summing up a bunch of elements. So let's imagine a situation where I want to sum up along either the rows or the columns of my array. So in the situation where let's say I want to add up 1, 2, 3, 4, then 5, 6, 7, 8, then 9, 10, 11, 12. Well, I like to imagine that we're collapsing the array in this direction. So we're turning all of these numbers, we're summing them up to make 1, then we're summing up the middle row, then we're summing up the last row. So because we're collapsing in this direction, this axis 1 horizontal direction, we use axis 1. On the other hand, if we wanted to sum up 1, 5, 9, and then 2, 6, 10, and so on, well, we'd be kind of reducing all of these numbers in this vertical direction. So that's why we want to use axis 0. Another common situation is concatenation. So I have 2 arrays, for instance, and I want to combine them into one array. You can think about, well, what dimension do I want to change when I'm combining these arrays? Do I want to add another column? In which case I'd be working with axis 1. And this arrow kind of picture still works because we're increasing it in this horizontal direction. We're adding another column in. Or do I want to add another row? Do I want to deal with axis 0, in which case, again, if we follow this direction of the arrow, we'd be adding a row. So again, without seeing a couple examples, that might still be confusing. So let's look at the first case that we talked about. So where we're dealing with some kind of arithmetic operation, maybe we want to sum up elements, for instance. So in this example, I have a 5 by 2 array. And let's say in one case, let's start with this sum along axis equals 1. So I want to sum in this horizontal direction. I can imagine collapsing my array in this horizontal direction. So the way this is going to work is we say, okay, well, I have 0 plus 1, that becomes 1. Then I have 2 plus 3 becomes 5. 5 plus 4 becomes 9. 6 plus 7 becomes 13. And 8 plus 9 becomes 17. On the other hand, let's say I want to sum along the axis 0. So again, following this arrow, we imagine collapsing all of these entries down to a single value. So I have 0 plus 2 plus 4 plus 6 plus 8, that becomes 20. And then I have 1 plus 3 plus 5 plus 7 plus 9, that's 25. So again, just to emphasize, notice in the axis equals 1 case, we summed in this horizontal direction, and we collapsed all of the columns down into one entry. So we were just left with the 5, or really we had 5 results of that, one for every row. On the other hand, if we sum along axis equals 0, what we're doing is we are collapsing all of the rows into one element in each column. So we went from a 5 by 2 to just a 1 by 2 in this case. One other example we can look at is concatenation. So in this case, imagine I have this nice 3 by 3 array, and let's say I want to combine it with this 1 by 3 array B. So I have A and B. So in the first case, let's say I have np.concatenate A comma B, and I want to do it along axis equals 0. So in that case, again, we're extending in this vertical direction. We're adding another row. What that's going to look like is we have the original A. Let's see if I can even copy paste it just to make it nice. So there's A. And then we take B. And we append it to the end of A. Something like this. On the other hand, what if I wanted to add another column to A? So as B stands, the dimensions don't quite make sense. So if I wanted to use axis 1, so again, I'm increasing in this horizontal direction, well, I wouldn't really know where to put B. So what we can do is we can take the transpose. So again, transpose means swap rows and columns. So B goes from a 1 by 3 to a 3 by 1. And then what we can do is we can say, okay, well, take A, increase in the horizontal direction, so add another column, and the new column is B transpose. So again, the way that's going to look, let's see if I can copy A. And now we use B transpose. All right, I hope that was helpful. I think this is where we'll end today's video. Thank you for watching, and we'll see you in the next one.